Hello everyone. We are going to see the function of simple microscope. Some simple microscope we are knowing. Microscope is a device used to see the object, a magnified image of a small object. For this purpose, convex lens is used. So see how the convex lens is used to magnify the image of a small object. So to show this, first of all, see, this is a line in which consider a convex lens here in a picture. L. Convex lens, their optical center O is here. Let focal point of it F and F, and a small object is placed here. See carefully, and a small object AB kept in here. Let's see, this object is kept between optical center and focal point of it. Let us make a ray diagram by it. The first ray parallel to the principal axis always passes through the focus. Another ray passing from optical center, second ray, this is undeviated. Now see in the diagram, so no image can be formed on this side when it is through the eye from here. So to make an image, let us see very carefully. When both the rays refracted ray proceed forward and this also, this refracted ray proceed forward, it seems to come from this point, join this both. A dash, B dash is image formed by this. It is set in this way. The object is placed, the small object AB is placed at a suitable place between this in such a way that the clear magnified image formed at least distance of distinct vision, capital D, is here, right? So by this way we can obtain the magnified image A dash, B dash here, which is taller than the small size. Now see how much time it will be magnified can be obtained by this formula. See very carefully to see it. The magnified formula is given by the magnification of a simple microscope is angle subtended by the image of eye. It is angle, ratio of two angle by angle subtended by object when it is placed at capital D. Capital D means least distance of distinct vision. Capital D is least distance of this vision. So capital D means this. Let us see angle subtended by the image at I. The image is formed here. This is the position of I at O. So angle subtended by it is beta. See in the diagram. By angle subtended of object when it is at capital D. So for this one more diagram is, see here very carefully. Same object AB is kept here. AB. And it is viewed through the least distance of distinct vision capital D. Compare in the both diagram equal. Capital D, we are knowing this is 25 centimeter, the least distance of distinct vision for normal eye. Then in the formula, angle subtended by object when it is at D, let visible angle make here. Here visible angle consider alpha. In that condition, see, visible angle beta is subtended on eye for final image, and without lens when it is viewed through the same object it made visible angle alpha. So the formula of magnification M by same formula can be written as beta by alpha. Let us in a mathematical equation represent by equation number 1. Now what we will do? We will obtain value of beta and alpha and will place in equation 1. So let us see the value of beta and alpha here in this. So first of all, see for beta. To obtain the beta, let us see the triangle. We are going to see triangle. See carefully. A, B, O. In triangle this is A, B, O. This angle is beta. Beta means we are going to obtain tan beta. It is perpendicular by base. It is AB by AO according to it. Represent it as equation number 2. This equation 2 obtained from figure number 1 here. Let this is figure number 1. Now see in figure 2. When we obtain beta alpha, here alpha is equal to, in this triangle, AB by, let this point is O, AB by AO. Consider this is equation number 3. Now what we will do? Value of beta and alpha from equation 2 and 3 we will place in equation number 1. In that condition, equation 1 can be written as beta. This beta is AB by AO upon alpha is AB by, this is seen one thing here in it. Here two things are become common, O and O. So this O we will take as O dash. Then here AO dash will be, it is AO dash. Now see, in this formula, AB is cancelled by AB. This implies that M will be, this AO dash will go up by AO. Let this is equation number 4. Now see carefully AO dash. AO dash. AO dash is this. This AO dash is a D in the left hand side. So this AO dash is a D and AO, we are knowing it is represented by U. So AO is U, and putting this value both in the equation number 5, magnification M can be written as AO dash D by U. This is equation number 5. Plan, what is the plan? Let us see. We will obtain the value of 1 by U and will place in equation number 5. So for that we are going to see length formula. This is 1 by F is equal to 1 by V minus 1 by U. See, simple convex lens, focal length is positive. Here U is negative and image is also from same side, so it is negative. So both is a negative, and this V is a negative and it is a minus D, forms at least distance of distinct vision. So keeping this value here, 1 by F is here. In place of B, we are going to use minus D, and U is negative, so minus this plus, it is 1 by U. Now see, by this mathematical expression, value of 1 by U can be obtained as 1 by F plus 1 by D. Now see, this value of 1 by U from equation number 6 we are going to place in equation number 5. So what is the final formula? M is equal to D. 1 by U is 1 by F plus 1 by D. Now opening the bracket, it is D upon F plus 1 is equal to magnification. This is equation number 7. So equation number 7 represents the formula to obtain the magnification produced by simple microscope, and it can be obtained only by knowing capital D and F. Capital D is the least distance of distinct vision, 25 centimeter, and only by knowing the focal length of that and keeping in this formula. This formula is applicable when final image is formed at capital D. See, it is at capital D. Now see, where is the position of image when it is seen through the relaxed eye? When we see with the relaxed eye, the image should form at infinity. So when it is possible to image at infinity, the object must be at focus. Let it is object AB. First ray of light, let this is a position of convex lens, L is here, always passes through the focal, another passes through the optical center. Both ray becomes parallel, so parallel ray will meet at infinity. So final image will be forms at infinity. In that condition, see carefully in the diagram, u will be the focal length of lens. In that condition, magnification which is given by equation 5, seen it, m is equal to d by u. It can be written as d by, in place of u, f can be obtained. So formula directly can be written as d by f. This is a formula for magnification when we used to see with relaxed eye. Here m is equal to d by f, and it is represented by equation 6. And see, this is the formula for magnification of a simple microscope represented by equation 7 when image is formed at a t, that is the least distance of distinct vision. So this is for the topic. Thank you and have a nice day.